Hello guys, in this video I would like to talk about assumptions of analysis of variance which we called ANOVA. Before this I have done a video about why we need analysis of variance. So if you would like to know about why we need analysis of variance and what is analysis of variance, you can just click on the link given in the description of this video and you can watch that video. So that will explain many things to you. Analysis of variance is actually a statistical technique which you can use to test the hypothesis about the mean value of three or more than three population. You know that we can use t-test for testing the mean of two population uh, using t-test. But if it is three or more, then you can use still t-test. But this you need to make various combination that can create difficulties, which is explained in the previous video. So therefore, we need to use analysis of variance to test all these means together. In this video, I would like to talk about the assumption. The assumptions are necessary, and you need to check these assumptions before carrying out analysis of variance. Otherwise, your result will be misleading. So let's see what are the assumptions and how we can check these assumptions. Okay, so these are the key assumptions are independence. The sample should be independent. The sample must be independent of each other. This means that the data should not be from the same source. Like if you suppose you are taking data from a group of people and then you apply some treatment and then you say again. So that's mean this can be a dependent sample. So the sample must be independent of each other. Okay, so this is one of the assumption, and this you can check with the Durbin-Watson test. You can use this test and maybe other test as well, whether the two samples are independent or not. The second assumption is normality. The data in each group should be approximately normally distributed. So this means that normally we need the normality assumption, but in the real life, maybe we don't have the maybe in the real life we don't have the exact normality, so we talk about approximate normality. So this means that the data in each sample should be approximately normal, in each group should be approximately normally distributed. And now how to check normality? Shapiro-Wilk test you can use for testing the normality of the data. Kolmogorov-Smirnov test is another test which you can use for testing the normality of the data. Anderson-Darling test and York-Bira test, these tests, all tests you can use to test the normality of the data. I have done a video on Shapiro-Wilk test and Kolmogorov-Smirnov test as well. And I mean, for the normality, I have used this all test. So if you like, you can click on the link given below. The link is normality testing. So you can go and click and you will see how these tests work to test the normality. I have done a separate video on Durbin-Watson test, so you can use this test. You can see the video on this test as well, which is the link is given in the description of this video. And maybe you can use other tests as well for independence of the samples of the data. Now, homogeneity of variance, which we call homoscedasticity, the variance of the different groups should be approximately equal. So this means the variance should be constant. That's mean equal. On if the variances are not equal, then we say that is heteroscedasticity. So homogeneity of that variance, you can homoscedasticity can be tested by Levine test or Bartlett test. You can use this test to test whether the variance of the data of the groups are homogeneous or not. So what we have done in this video, we have done about the key assumption of ANOVA, that is independence, normality, and homogeneity of the variance. And then we learn that how to test and which test we can use for testing these assumptions. So I think this is enough for today, and see you in the next video. Ciao.